I late? Am I late? I'm not late. Let's do another kata. Hello and welcome to another Bringing the Thunder. We're doing another exciting kata exercise today, and I have with me a new guest. Always fun to get someone new to come on the show here and actually show us some interesting things. I think a little birdie told me that today we're going to be looking at alarm templates.
I think that's right.
Well, I hope you think it's right.
We can do that.
Okay, but let me tell you, or ask you the first question I always ask everyone, and especially if you're a new person at the show, who are you and what do you do at Skyline?
Well, my name is Michiel, and currently I'm involved with media ops.
All right.
Okay. Something new that's coming out with the Empower event that's coming up here in HQ in June.
Nice.
I think it's
nice.
11 to 13 June. We're going to talk a little bit more about media ops, what it does and what it can do for organizations.
A quick sneak preview on something to come here. Amazing. Yes. But today it's alarm templates.
Yes.
Something that's been in DataMine for a while, and it's been really a core facet of the entire point of monitoring and automating things. It all starts with having something automatically detect a problem.
Yes.
Okay. So you've prepared for us a little exercise, a tutorial. Are there any prerequisites we need to know of?
Well, you need a data miner system for sure.
Convenient to have a data miner system.
And a cloud connection towards that data miner system so that you can deploy the connector that we're going to use from the catalog.
All right. So, and can we do it on a DAS setup or?
Perfectly fine, because if you spin up a DAS, it's automatically cloud connected. So that's actually what I'm going to do. I'm using a DAS here today. That's spin up especially for
just for this kata.
Just for this kata.
And you mentioned a DMAP or an installation package. So yes. I'm gonna guess similar to other katas, going to the catalog and then deploying that. What is it called? How do you find that?
Well, currently it's only a protocol that we're gonna deploy.
Okay.
And we're gonna create an element from that protocol.
Okay, great. So a little protocol that we need to grab from the catalog. And do we know the name of that one?
Yes, let me show that to you.
Yeah, for sure.
So here on the catalog, if we're gonna search for, I already have it open actually, but if you search for generic data simulator, this one, then you will come to this page.
Okay. And you can just deploy it?
Yes, because I am in Skyline Communication, I can deploy. Other people will probably see deploy trial. No problem, they can deploy the trial and use it.
Okay, all right, so if you're having a look at it, you'll probably see deploy trial. That's fine, do so.
Yeah.
No strings attached.
We're going to deploy it now on our Kata DAS system. And once that's done, then we should see it appearing in our system here in our DAS.
All right. Okay, so it's a connector and it's called generic data simulator. I see it just appeared there. So we're going to make an element.
Yes, but before we create the element, I think this is an important step. We're going to set a production version for this one.
Okay.
This way, if we create alarm and trend templates on the production version, they will automatically be taken to the next version. Because if you create them on the version 101, then you have a new version and you change the version, the alarm templates, you will need to duplicate them. So if we create them on production, they're automatically taken with the production
version. So a really good tip already right out of the gate. If we set that to production and we start making templates, they'll keep going along with whatever is currently the production version, keep going up. Okay.
Exactly. So now that we have that, we can create a new element. So let me do that. And in here, we're gonna just call this one data simulator. You can give it your own name. And then we're gonna say generic data simulator, use the production version, and then create. And then we will have our element created, and we will see two pages, a general page and interfaces page.
Okay.
We will start off with the general page where we have two parameters where we want to apply some alarming on.
Okay, so I see the CPU and then a counter parameter.
Yes, but before we are actually going to start with alarm templates, I'm going to enable trending just so that we can see how it behaves over time.
Oh, right.
But that's just so that I can demonstrate that for you.
All right. Some of the things will involve needing a little bit of data from the past, so we set it active and then we can use that during our...
You can use that indeed, yes.
Okay,
cool. So I'm gonna, sorry, not simulate mode, the counter parameter, and the CPU, and then the bit rates on our interface table. And once I do this, you will see that our trend icon appears here so that we can follow along how the value evolves.
Now, is this connector doing actual polling, or is it's all simulated?
It's all simulated.
So we're not actually grabbing the CPU or doing any OS calls, anything?
Because I wanted to have some different ways of how the CPU behaves. I would like to...
would it be difficult? Otherwise you need to use while loops and start programs and stuff.
So that's why I have here a simulation where I can then select low, high load or spikes to simulate different behaviors on the CPU.
Excellent, perfect. Okay, so perfectly fine to use on a staging setup or on a DAS setup. Doesn't actually do any communication, just a small simulation there.
Indeed.
Great, okay.
So the next step is our alarm template. So we're going to...
The main step, I would say.
Going to assign alarm template. We don't have one yet, so we're going to create a new one. I'm going to call this one defaults, and then you can see version production, and then OK.
Okay.
Now I can see all the parameters that are available in my element appear here.
Yes.
And that's basically for me now to define. The first thing I would like to alarm is the CPU. And when I check this box, you can see that there are already some values pre-filled.
Yes,
this is
some
because
default values are in there. Okay.
indeed the developer that created this connector thought 60% is normal, 70% is normally an alarm, and so on.
Okay.
This is a default, you could say. You can still change this, and I would recommend everybody that has a data miner system to think about the alarm severities as well. This will help a lot for your operators if they see, for example, a critical alarm appearing in their console.
What does it mean?
Yes, is this now a service outage? Do I need to attend to this alarm quickly? Yes or no? And if you define some definition to these alarm levels, it will also help your organization to digest your alarm control.
Right, because indeed we provide values like critical, major, minor, but that doesn't really have a meaning maybe in every organization. It might mean something else.
Yes, so if everybody just creates his own alarm templates, defines whatever threshold on it, then it might get messy at some point.
Okay, cool, good tip. Another one.
So let's do this one. So we're doing normal alarming here with some thresholds. If we do this, we can see that now our CPU is in a normal state.
Very well,
24%. So now if I would say, for example, I'm going to simulate some spikes, then at some point it should go to 90% from time to time. And then you will see normally, and now you can see it already, that an alarm pops up. And then you can see this, but normally now it pops off again because it spikes. So for an operator, this can be challenging because he sees like alarming popping in and out.
Yes.
And he's not able to figure out what was this actually. So there are two ways that you can do this. You can look at the history of your element by dragging your element and then say, I want to see last hour.
Okay.
And then show
drag
these,
and drop.
and then show these alarms. And then you will see the alarm that happened on the system. But sometimes you also will not have seen that alarm popped in and out. So maybe you want another option as well.
Right.
And for that, we have hysteresis. So if we go back to our alarm template, here you can see, maybe I'll hide the surveyor for now, that we have a little bit more screen.
Very well, yes.
Hysteresis off and on. So what does this mean? If I put, for example, hysteresis on to 10 seconds, it means that my value needs to be in that severity for at least 10 seconds before the alarm is created. So if I now apply this and I go back to my element, you should see that it goes to 90% at some point, but it won't go into alarm because
unless it's 10 seconds.
Yeah.
But you made sure it's not 10 seconds.
Yes. Because I simulated
in the generated simulation. Okay.
So that this could be like for CPU, if it sometimes go to 90%, you're not too worried. So I don't want to have an alarm at all.
It is kind of normal behavior in a lot. You're using your resources as you have them. Yeah.
Yeah. So now you see 90% and it's still normal. Some cases, if something happens and it goes away again, you don't want the alarm to be cleared because you want to take action on it. And for that, you can also use the hysteresis off. And then you can also define, for example, some value on that, like 20 seconds or whatever, so that if it gets into a critical alarm, it will stay in that
for 20 seconds.
For 20 seconds, so that it doesn't immediately disappear again for the operator. The operator will have at least 20 seconds to look at the alarm. You can define higher amount.
I mean, 20 seconds still pretty hardcore, I guess. But
this is just for the demo, of course, that we don't have to wait minutes.
Put it on an hour and then come back for have a drink.
So now if we simulate, for example, high load, we should see
That the alarm happens after
let me
10 seconds.
yeah, that after 10 seconds that it's in high load, it will generate an alarm. So now we can see it's already going to 90%. And after some time, 10 seconds normally, you will see that an alarm is generated.
All right.
This will help your operators to digest your alarm console and limit the number of alarms that are being generated in your system so that you also prevent high load on your system.
Yeah, if it's something that keeps coming up and down, this is indeed a perfect way to give everyone a little bit of time to, like they say, digest the error and have a look at what caused it, what's the root cause. Okay,
Indeed.
cool.
Exactly. So that was one example.
So hysteresis, how do you say that? Hysteresis?
Hysteresis.
Sure.
On and off.
Okay.
Let me put it back to low load. There is another one that I wanted to show. Sometimes we have counter parameters. For example, on switches, how many packets or bytes that go through your interface. And those are things that keep on increasing, but they never, it's very difficult to say I'm going to define a lower limit and an upper limit because they just increase from 0 to max value and then jump again. It's like a suitate pattern. Salty, however you call it. And now with the low load, it will increment with 1 every time, so you can see that. So how could we alarm on this? Currently, I have only the monitored parameters.
Yeah, because it just keeps going up, so it makes no sense to use what we just did, because those were fixed values.
Yes.
So otherwise, you'd go into critical after 60, but what does that mean? That doesn't really mean much.
Yeah, no, indeed. And for that one, we have a other option. So under counter parameters, you also have rates. And this is basically to say the normal rate is between this and this value. If it increases with more than X amount, then something is wrong. So in here, I'm going to say now, if it increases with 2 and with 5, for example, then it's critical to an upper limit. You could also say if it doesn't increase, if it remains 0, for example, you could say also.
So is that an item per second rate or an item per
update?
Minute per hour?
Per update.
Per update.
If, as far as I know.
Okay.
So now you can see it's normal because it keeps increasing with 1. Let me open my alarm console as well so that you can see what happens if I put it back to high load.
Right, per update of the parameter you meant. So anytime you do a set parameter or anytime you change that value, it will look what's the difference in time and the difference between both values.
And
probably.
then you can see 5 bytes more during the last 5 seconds.
Perfect. Okay, so
my updates are every 5 seconds actually.
Okay.
So this is a way how you could then alarm if your rate starts to increase too fast or too slow.
Okay, cool. That's very cool indeed. Okay.
Then to go to this one, tables. That's maybe another challenge sometimes, because in tables we can define alarm templates on the columns, but sometimes inside of your table you can have some rows that represent audio, some that represent video.
Video could be both. It could be a lot of stuff.
Audio, you expect a different bit rate than for video, so defining thresholds again can be a challenge. There are also some tricks there.
Okay.
Let me show that as well. And our alarm template here, going back to all protocol parameters, bit rate. So here we have relative and absolute.
Yes.
That would be based on a baseline then. So if I say, for example, I'm going to do relative alarming, that means that if I deviate from my baseline with X amount of percentage, I want to create an alarm. So then again, I can define some percentages that it is over the baseline.
Right, so you're specifying a certain number, a certain value, and you're saying that is what it's supposed to be in a normal situation. And then you can say make it a critical or a major or a minor error depending on how much it's above it or under it.
Indeed. So now I applied it, but you can see actually that no alarms was generated.
Yeah, I was going to say, what's the baseline?
Exactly, that's the thing that we need to define.
What's the baseline, Michel?
So we click on that baseline. Sometimes hard to find if you do this for the first time. But you click on
you just click on it and then you can.
And then you can see here the current value and the baseline value.
Right.
If you don't know what the baseline value should be, you can say if these are all the values that are now in there.
And those are normal?
Or normal.
Okay.
I can just select them all and say, use the current value as baseline value.
And you can multiple select all of them. And
Exactly. Or if you have large tables.
quick tip, nice, again.
Then you don't have to do one by one, fill it in manually. You can just copy basically from the current value.
Okay, and now you've pretty much said, okay, well, what I was seeing right now, I know that's normal. So you've defined that as the baseline, and now you're
And then you can
covered.
see here in this case, we have one that is an alarm. That's probably because here we have a larger variance simulation. So it deviates more compared to the others. So
Right.
that's why that we saw this one going into alarm.
Yes. Okay, so that's no longer a static value where, like in the beginning, we said if it's higher than 40 or 50%, you go in alarm. And then the other one we saw was the rate. So if it changes at a certain amount of time, we go in alarm. This, we also saw hysteresis already.
Yes,
If it's 10 seconds, then go into alarm.
yes.
So timing based. And now this one was specific for tables? No, this was specific for every parameter.
Yes, we can do this for every parameter.
Relative and, well, absolute. We also, you mentioned absolute as well, but
Yes,
it's
relative and absolute, you can use that on single parameters as well. But in tables, it's very handy, of course, if you have
a large amount of, yeah.
values in your...
So, and now we did it with relative, which then has the baseline, and then you set the percentage.
Yes, and that can be tricky, especially if your values are very small.
Yes.
Imagine that you have, for example, a value that varies between, very close to 0. 15% of something close to 0
Yeah.
is very, very small.
Yes.
So that can be a challenge then to do that in that case. So,
Okay.
if, for example, for smaller values, you could also, in here, duplicate this row.
Okay.
And then do something different, for example, for some rows. And we're going to need to apply a filter here. Currently, it's a wildcard, so it means it matches all the rows in our table.
Okay.
But we can also define, like, it needs to match something. So in my case, I'm going to say ethernet 1/1. That's my display key of
I
the
was
first
going to
row.
say, what does it look at in the table? Which column is used?
Well, that's a good question, because we have a primary key and we have a display key.
Yes.
Typically, the display key is the one that is most interesting because it makes more sense typically than the primary key.
Right. That's the one is usually marked with the IDX in the name. Right?
Exactly. So developers, by convenient, mark it with IDX so that you immediately can spot which column is actually the
Okay,
display
so the
column.
filter is going to be looking at that column.
Exactly.
Okay.
So now we're filtering basically on the Ethernet one, and there we want to do something else. And now we're going to do, for example, absolutes. And then the values could be, for example, 0.2. And then here, 0.5 megabits per second. And then this one is 0.2.
All right, so that's the difference. Relative or percentage based, and absolute
Yes.
are static values, either higher or lower than your baseline.
Yes. So now if I look, then this one should have different alarming. Maybe I'll increase the variance here to 0.3. And then on the next iteration, you should see normally that it starts to alarm.
Right.
So if I now also increase the value to 10, for example, which is a higher value, then percentage-wise, this would be no longer in alarm because we are now using absolute.
Okay.
It remains in alarm.
We can also, you just changed it, that's why I noticed. We have a column there that actually indicates the baseline as well. Is that then the same thing that we saw in the UI of the alarm templates?
This one in the data simulator.
Yeah.
Yeah, this one is just for simulation. I use this one to simulate the data. So
Okay.
normally your device will return a bit rate from
Yes.
your Ethernet interface, and that's something that is
Okay.
given from a device.
Okay, I get
But
it,
For
I
me
get
to
it.
simulate this data and to play with the values, I use
Yeah,
basically
yeah.
these two columns
So
to simulate the data.
Those two columns are just for data simulation, and
Yes.
there the name baseline just means it's for your simulation. It's
Exactly.
what you want to go up and above. The actual baseline that we were looking at is in the alarm console
templates.
and alarm template. Sorry.
Yes.
Okay. I just noticed it. I was like, what's going on? But okay, good.
Then something important, if you add multiple rows here with a different filter, is that you always put the most restrictive one on top, because in your alarm template, it will go through it, and the first one that matches will actually be used. So if I would change the percentage here to the top one, to this one,
It
and
will
now
always match.
apply this one, and then it will do it
Always
based on
with
percentages
relatives.
and not on the absolute. So
Okay.
it depends on the order that you
So it's
define.
top down, and if it finds one that matches, it stops.
Exactly.
Okay, good to know. Another really good tip.
And yeah, so you can play around with these arrows to change the order.
Cool. Okay.
Maybe something else that I also wanted to show you.
Sure.
Imagine that, the interface is no longer used. Then typically what you would see is that the value of that interface will go to 0 megabits per second. And then you will also expect an alarm because 15% of 0 is 0. And it's an alarm.
Okay, like that.
Yeah.
Okay.
So, but now, typically, what happens on these interfaces, operators will set them to admin down. So, to indicate that part should not be used, it cannot be used by connecting a cable and so
Let
on.
me guess. At that point, I as a user would no longer want my alarm.
Exactly. So that's something that you could do with conditional alarming in your alarm console.
Okay, conditional alarming. How does that work? Teach us. Show us.
This is a condition, and normally this one should explain the parameter is excluded if the condition is true. So it's the way around, actually. So you say, I want to use a new condition on this row, and I'm going to say it's my admin state that I'm going to use as a condition. You can give the name actually as you want. And I'm going to look for the admin state in my table. So in interface table, admin state. And I'm going to say if the value equals down, I don't want alarming. So it's going to be excluded
So the
if it matches down.
Condition there is, like you said, it's a little, you need to think about it in that way of what you want to stop alarming. So the condition is when do you want to stop alarming when this condition is true, in this case when the admin state is down.
Exactly. Cool. And now I'm going to apply this to these two rules, apply this alarm template, and normally now I should see indeed I no longer have an alarm here.
It's completely gone. It's not even normal or maybe.
Exactly.
Okay. Cool.
So that's a quick tutorial, you could say,
on
how to use alarm templates.
Pretty nice. And
something that is can always be tricky a little bit is that your baseline value could change over time, and then you need to change because maybe today you have only audio, tomorrow you have video and audio, and then you have to update that baseline continuously.
Suddenly goes from SD to HD, and then the throughput is like a lot bigger. So
and then you need to have an operator that continuously changes these baselines. So there is also an option for you to make it easy for you, and that's to automatically update these values based on the trend graph. So then data miner will look at the past X amount of days that you configure here. You can also skip the last X amount of days to avoid if it slightly starts to go down, that you can detect that as well. And then the baseline will basically be calculated for you and you no longer have to configure it. But this will only work from the moment you have 7 days of trending. So if I now would enable this, it would not work.
You just enable trending.
Yes, exactly.
Okay, we just wait for 7 days. We'll play some music and we'll just
7 days later,
just freeze frame for 7 days. No, okay, let's not do that. Okay, so but anyway, if it was 7 days of trending, it would automatically calculate what's the average that it's been, and then that would be used as the baseline, and it's like, what is it, like a sliding window? So every day after that, it recalculates. So would you know?
Well, yeah, it's gonna use always
7 days in back. So it's
7
always
days. 7 days back. It's gonna slide in.
It's a sliding window. Yeah. Okay.
And then there is one more thing that you could use if you have, for example, bit rates that are over day different than overnight. Maybe the power consumption over day is more than overnight.
Yeah.
Then that one can also fluctuate.
But
based on
within just hours of each other.
Yes. So then you cannot say I'm going to calculate it over 7 days, because then you would need a very big variance or percentage relative or absolute value to put, and it will not be very helpful. So then you can say I'm going to detect daily patterns, and that one will use in blocks of 15 minutes in the last X amount of days that you configure. What is the average values for that slot of 15 minutes over all those days? And then calculate what the baseline value was in the last X amount of days during that 15 minutes.
So it's a little more clever in that you're just saying, check every day on a specific window of time where you know that's kind of what usually is normal behavior. Cool. Okay. Any other really amazing tips, or is there anything they should screenshot for this exercise if you want to make some nice DevOps points? What should they do?
Well, I think from the moment you were able to create this template, and you can show us with a screenshot that you have rate, normal, absolute, and relative, that you have played around with it, that you understand those concepts, and you can send that one in. I think they are earned their points.
Yeah. It's really been interesting. So indeed, if you have done this, if you can take a screenshot of this situation, this setup right here, we'll get you your DevOps points, and you can consider another check mark next to another kata that you've successfully completed. Then, Michiel, was there anything really important you still wanted to show us, or was that about it for the tutorial?
I think in 15 minutes I will say, shit, I needed to mention that one as well, but at this moment I cannot think of it.
Children are watching, you cannot swear. No, that's fine. No. We'll put a duck over it.
Yes.
No, it's fine. Great. Okay, well, everyone watching, thank you very much for paying attention. Michiel, thank you very much for preparing, coming and showing us all of these amazing things. Always welcome for an addendum or something else. And everyone watching, if you are looking from YouTube, don't forget, like, subscribe, ring that notification bell so you are always aware of any new videos that we bring out. Other than that, I think that's pretty much it. So I'll catch you guys on the next one. Good luck.